Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find BP? Take a moment to study the figure. Then let us uncover the two ideas that make the solution click. The blue square has area 5. M is the midpoint of its top side, and segment BP meets segment MC at a right angle. Our target is the red segment BP. Use the square area theorem directly. If S is the side length, then the area of the square equals S squared. Since the given area is 5, S squared equals 5. A length is positive, so S equals the positive square root of 5. Every side of the square now has that length. The two strong equality marks show that M is the midpoint of segment AD. Therefore, segment AM and segment DM are each half of the side. Substitute the side length. Segment DM equals root 5 over 2. This half side is the short leg of the first right triangle. Now focus on triangle CDM. The square gives a right angle at D, so segment CD and segment DM are the two perpendicular legs. Apply the Pythagorean theorem once. The hypotenuse segment MC squared equals segment CD squared plus segment DM squared. Substitute segment CD equal to root 5 and segment DM equal to root 5 over 2. Their squared lengths add to 25 over 4. Here's the first insight. The midpoint fixes the leg ratio inside triangle CDM, so the diagonal segment MC is forced to be 5 over 2. We have determined it before touching the target segment BP. Now use the right angle marker at P. It tells us segment BP is perpendicular to segment MC, so triangle BPC is right-angled at P. The square also gives segment CD perpendicular to segment CB. Angles D, CEM, and CBP are acute angles whose corresponding sides are perpendicular, so they are equal. That is the second insight. Triangle CDM and triangle BPC each have a right angle and one matching acute angle. By angle-angle similarity, they are similar, with segment MC corresponding to segment CB and segment CD corresponding to segment BP. Write the proportion using corresponding sides. Segment MC over segment CB equals segment CD over segment BP. Substitute segment MC equal to 5 over 2, and both square sides, segment CB and segment CD, equal to root 5. Cross multiplication now gives 5 halves times segment BP equals 5. Multiply by 2/5. The target length segment BP equals 2. So the red perpendicular segment BP is 2 units. The area fixed the scale, the midpoint fixed segment MC, and the two perpendicular pairs revealed the similar triangles. So the final answer is 2. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.